Hi guys, welcome to the final instalment of our bivariate data analysis bit of unit of work. Now just to recap, we know this is bivariate data because we've got two different sets of data. In this question it's height and arm span that are somehow possibly related to each other. And it's the relationship between these two variables that we're going to be trying to find and essentially predict different heights or arm spans based upon our findings. Okay, one other thing just to quickly settle is the idea of independent and dependent variables. So the independent one isn't caused to change by the other variable, whereas the dependent one really relies on the other variable to change. All right, so in this example, the height is the independent variable because it's the arm span that will change depending on how tall or how big someone grows. All right, now in this unit of work or this little idea, you're going to be asked to do two things. One is to, as it says here, find the correlation coefficient, R, or two, find the equation of the least squares regression line. Now the first one, correlation coefficient, it's sometimes called Pearsons correlation coefficient. Now the good or bad news that you might take is both of these ideas require heavy use of your calculator in stats mode. So it's something well worth practicing and something making sure you're really familiar with for your upcoming exams. Okay, I'm going to guide you through these steps. Mind you, I'm doing it for the Casio calculators that most of us have at school. If you have a different brand calculator, I suggest you come and see one of us or use Google to try and find out exactly how to do these same processes on your different calculator. Okay, so the first thing I need you to do is to turn on stats mode. Okay, so to do that in your calculator, you're going to press the mode button in the top right corner, followed by the number 2, which says stat. Okay, now when you do this and you've pressed mode then 2 for stat, you're going to get a screen that looks somewhat like this one over here. Now, at this point in time, you do have a couple of options. The one that we're going to use today and most of the time in this unit of work is going to be by pressing number 2. Okay, so that value 2 that says a plus bx, what that really is it's mimicking a straight line. All right, so really what it's talking about is y equals mx plus c, just written in reverse, where you've got your gradient at the back and your y-intercept, that a value, at the front. And we'll see a bit more about those letters A's and B's and how they work with the calculator in a little bit. So just go ahead and press that number 2 button and we'll move on from there. Okay, so we've pressed the number 2 button and now we're faced with this screen where we've got an x and y and some values down the side here. What do you think this is going to be used for? Yeah, that's right. It's where we're going to enter our data in. Now we've got our two columns, x and a y column, and that x column is reserved for the independent variable. In this case, it's the height, and that y column is reserved for the dependent variable, in this case being the arm span. So you can go and enter that data, all the heights going down that x column, and all the arm spans, the y values, going down that y column. Okay, so now that you've given us a big tick from entering your data, I just want you to press the all clear button, the AC, the big orange one. What that's going to allow us to do is to get out of that data entry mode and start analysing. Don't worry though, your data is still there. If you do want to go back and enter it, you just press Shift 1 and 2 for data and you'll go back and be able to see all your data or change it. All right, we're going to assume we're happy with our data. We're back to the home screen with a 0. We're still in stat mode. What I want you to do now is press Shift followed by the number 1. All right, it's going to take you to this screen over here where we've now got a few more options, and the one we're really concerned with for this piece of the unit of work is this number 5, that reg button or regression. All right, remember we are going to end up finding our least squares regression line. The one we may have used before in our probability unit is that VAR button, and that lets us go and find the means and standard deviations of our data sets. Okay, so we've pressed 5 and we've finally got to the juicy part of our information, and we're going to use lots of these values over here to answer those questions. So let's start off with the Pearsons correlation coefficient. Okay, so to find the Pearsons correlation coefficient, we're just going to now go and press the number 3, which gives us that R value. Okay, so for this data set, the Pearsons correlation coefficient should read 0.98. Alright, so that being a really strong, almost perfect relationship between height and an arm span. Okay, so the next part, which is probably the more difficult part, is this least squares regression line, although it does still just rely on us being able to use the calculator and remember these steps. Okay, this least squares regression line is based upon the idea of y equals mx plus c. Although, when we're using the calculator to find it, unfortunately we don't have those letters m and c. We're replacing them with these two values, the number 2b value and the number 1a value. Now the way you might want to actually remember it is like this. The y value is equal to bx plus a. Now if you remember that very first screen that we pressed after our stat mode, it came up with the values that said a plus bx. This is now the thing we're going to be using, where we've got our gradient b and our y-intercept a. So now I want you to go to your calculator, and in here write in the value to 2 decimal spots of your b value, and then onto it add that a value onto the end. Let's see what we get. Okay, so we're going into those values. We're getting a negative value for c, which is okay, it's fine. And we're getting that value of 1.13 for our gradient. So if we go and write our least squares regression line in full, it's 1.13x minus 22.32. Right, so there is our equation of our least squares regression line. Okay, so now I'm getting the feeling that you really want to know what these two things are actually used for. Well, Pearsons correlation coefficient, that's the value, the official value that tells you about the strength of the relationship. Right, obviously, 1 is a perfect relationship or correlation. -1 is a perfect negative correlation. Anything in between makes it that little bit weaker. We're eventually getting down to 0 where there's no relationship. Okay, now into least squares regression line. Normally, when you've got your figures for your scatter plot, your coordinates, this is that line of best fit, the official line of best fit, that can now be used to make predictions. Alright, so you can predict inside the graph, so anywhere along that dotted line, which is called interpolation, or you can imagine that that graph is extended in either direction and extrapolate and make assumptions for outside the area or scope to where your data sits. All right, but it is all about making those future predictions now that you have the official line of best fit that matches your data. Okay, so that's our Pearsons correlation coefficient and least square regression line. Okay, but before we finish, there is a secondary method for this least squares regression line. This method is used when you have the data summarized already for you. This is when you don't have the original raw data to use and you've got some summarized notes about the data, in particular the means and standard deviations of both independent and dependent variables. And you're going to use it to find a least squares regression line. Okay, so in this method, your line of best fit is still used using y equals mx plus c. However, the way you find m and c is just a little different. Okay, so again, this is when you normally do not have the raw data and you're given some summarized information. All right, so first of all, our m value. We're going to find it by multiplying the Pearsons correlation coefficient, R, and in this case you'd be given it in a table or a value. You're going to multiply it by the standard deviation of the y-scores over the standard deviation of the x-scores. And then our c value that we're going to go and plug into the other side of mx plus c, you're going to get the mean value of the y-scores, take away the m So the value from over here times the mean value of the x scores. All right, so obviously you have to do that left-hand side. You have to do the m first because it's used in the second leg of this process. And then you tie all your answers together by writing your y equals mx plus c, where we get the values of m from this answer, and then we get the values of c from this answer. All right, so since we already have the data from this original question saved in our calculator in stats mode, why don't we actually go and find these other values manually, just so we can check and see how it works. All right, so remember, once you are in stat mode, we're now going to press Shift, followed by the number 1, and then we're going to press 4, which is our VAR. That will get us into the section where we can find means and standard deviations. Okay, so let's go into there, and how about you go and write down the values of your means and standard deviations for both x and y. Okay, so there we have our values for our means and standard deviations of x and y. The next thing we do have to do, because it is part of this formula, is go and find that Pearsons correlation coefficient by pressing 5 this time and going into our reg, and then pressing 3. Now we know this one from before because we've done it in the calculator, and that was our 0.98. Okay, so just to recap, remember this method is normally used when you do not have the raw data, when you do have this information in our blue box over here, pre-given to you. All right, so let's go and find this m value. In our calculator, we're going to put 0.98 times our standard deviation of the y, 4.88 over standard deviation of our x. We'll whack that in the calculator. Okay, and there's our m value. Now remember, we're going to need to use that on this far side, because finding our c, we're going to do the mean of y, 196, take away that m, 1.13, times the mean of x, 193.7. All right, I'm going to use the real full version, the non-rounded version of m, when I go and enter it in over here though. Okay, so I'm using the answer button to do that, and I get negative 22.48. Okay, so now we have our c value. We're going to write it as our equation, y equals m x plus, but in this case it's a minus, c. Okay, we've seen something very similar to that just earlier. We're out by a tiny bit over here with the y-intercept, probably just because of some rounding that we've done in summarising this data. All right, I hope you enjoyed that lesson. Now you can go and practice some of those questions from your work booklet. Nicola, if your class needs some help today, you're more than welcome, just for this one occasion, to come up and join my class so I can show you.